Hello guys, welcome to another episode with Talks with Edo Evergreen, where we get to talk about web development, software engineering, tools across different software teams, and basically dev tools. So for this episode, we're gonna talk about Cloud Phone. So this might be kind of different from what we talk about regularly on the podcast, but this is just a different approach to introduce the audience to Cloud Phone, what Cloud Phone is, and how developers could start building with the available APIs from the Cloud Phone team. And for this discussion, I brought in Tom to have the discussion with me. Hi, Tom.
Hi, Ida. Thank you for having me.
Amazing. So let's just quickly jump into the discussion, right? First off, just give us a quick introduction of yourself and what you've been up to.
Yeah, for sure. So as you started to allude to, I'm currently the head of developer relations for Cloud Phone. Cloud Phone is, you can basically think of it like an app store, but for 4G feature phones. And for those who aren't familiar with feature phones, think like old Nokia, like the one I'm holding here, something with a T9 keyboard and a basic, small screen. Sometimes they're flip phones. They go by a bunch of different names, but they're still a major device category in the world, still over 200 million plus units sold. And Cloud Phone basically allows web apps, like progressive web apps, to run on these devices without making them any more expensive. And most importantly, they run on devices as cheap as $12 US, unsubsidized. So it's not like a smartphone that might be 60 or 80 bucks that you have to put it onto a payment plan and make payments over the course of a 2-year term. This would be the full cost. And the way that we do this is using a Chromium-based remote browser. So the company behind Cloud Phone, CloudMosa, has been around since 2009. They're most known for a product called the Puffin browser, which had over 150 million installs around the world. And Puffin was basically, the browser lives in a server, and there's a thin client on the actual device that does all of the rendering. And that's the magic technology that makes this possible to run full websites. Like you can stream YouTube videos, watch TikTok, you can go on Facebook, all on phones with as little as 16 megabytes of RAM. And for most web developers today, that's like an unheard of, low bar in terms of the technical capacity of the devices that we're operating on.
Okay, amazing. So can we just quickly talk about, before we jump into the technical aspect of Cloud Phones and the APIs, right? Let's just quickly talk about the problem it solves, right? Can you just give us the particular, like some list of problems you feel like Cloud Phones actually solve in the market currently?
Yeah, so probably the biggest problem that they're solving is they're giving users a reason to upgrade as telecommunication operators are transitioning and sunsetting a spectrum from 2G and 3G over to 4G and 5G. So as you're probably aware, countries around the world have been trying to make this transition happen, but users haven't had a compelling reason to want to upgrade their phones because there's no additional services that you would get if you just transition to, like a 4G LTE feature phone. Cloud Phone gives them a whole range of features without impacting the price of the device. So again, as I mentioned, you can learn, you can watch videos on YouTube. I run a podcast app called PodLP, so you can listen to podcasts. You can communicate with your friends on Facebook. You can access maps through a Maps app. So there's a wealth of information that you can get from the web available to you on these feature phones. So really it's giving users a compelling reason to want to make that transition without sacrificing all the things that make feature phones still a valuable device category, namely their affordability, durability, and the long battery life that they offer.
Okay, amazing. So thinking about similar phones, right? Similar phone platforms like iOS. So can you just give us what's the difference between Cloud Phones and a particular phone operating system like iOS? So what differs? What's different between these two different phone platforms?
Yeah, and I'll maybe introduce KaiOS for your audience for anyone who's not familiar with it today. So KaiOS is a product that launched in 2016. It's based on Firefox OS, and it is a mobile operating system that works on feature phones, but it is fully browser-based. So because it's based on Firefox OS, everything that's happening behind the scenes is happening within a browser. When you get notifications, when you roll your status bar, when you open the app launcher, each one of these is a web app written in HTML, CSS, and JavaScript. So from a developer perspective, it meant that you could take web apps and ship them onto devices like feature phones relatively easily. But where the two differ is in both their technical approach and the market segments that they're targeting. So KaiOS is what we call a smart feature phone. That means that they're using the same type of hardware that you would expect in a smartphone today, like a Qualcomm 215 system on a chip that you'd expect in a low-end Android Go phone. That means that the price of a KaiOS device is substantially more than a basic 4G feature phone, sometimes between 2 and 4 times the total cost for one of these devices. I think the other biggest thing from a developer perspective is that KaiOS, because the whole operating system is a browser, it ships with the rendering engine and it will never be updated. KaiOS 2.5 runs Gecko 48, which is Firefox 48, that dates back to, I think, 2014 or 2015. That means that you're writing web apps that need to work on a browser that's a decade old. It also poses security risks. So the primary benefit of using CloudPhone is that you get all of the benefits of a budget 4G feature phone, namely the fact that they're much more affordable, but you still get to access a bunch of critical services through the CloudPhone app. And if you're a developer, the primary benefits are that you don't need to worry about optimization because we're rendering on powerful servers. So you don't need to think about the constrained hardware that you're running on. The servers are more than capable of running basically anything, and you don't need to worry about backwards compatibility. So CloudPhone's currently using the Chromium version 128 engine, and it gets regularly updated. That means that you have full access to everything from Canvas and WebGL to build games. You have real-time communication with WebSockets and Fetch. So you get a whole wealth of new modern tools, and you don't have to worry about necessarily the device that you're targeting beyond a few, considerations like fitting to the small screens and handling keyboard input.
Okay, cool. So some time ago, right, I think Android introduced what we call Android Go, right? And thinking about it now, I'm thinking about Android Go could be like a particular competitive market for cloud phones. So what do you think are the comparisons between cloud phones and Android Go? And we could talk about in terms of accessibility or affordability, because I think back then Android Go was very, very affordable. Like it has most of the Android features, but with some taking out what now with some features taken out from your regular Android device, right? So can you just give us the comparison between a cloud phone and an Android Go phone based on affordability?
Yeah, thanks for bringing that up. Android Go is definitely another option in the range of budget mobile devices. So
yeah,
I think the key difference here again is going to be affordability. So a cloud phone device, they're currently the market average for these is roughly between 12 and 20 US dollars. A couple of the ones that I pulled in India, for example, one of our biggest markets, they're selling for about 1,500 rupees, which is roughly about 17 US dollars. Compare that to some of the cheapest Android Go devices today, new Android Go devices. They're selling for about 6,000 to 7,000 rupees, which is about 75 US dollars. So again, we're talking multiples in terms of price. And for the average Indian who might be making 25,000 rupees, give or take, and that's a median across an entire country. That's a substantial amount of your monthly income that you'd have to devote to a single device. And again, that's a median, so that means that there's more than half of the country making substantially less than that. So for millions, hundreds of millions of people, Android Go is still not affordable enough. Now, technically though, Android Go is the full Android operating system, just with a few limitations or features removed, so it runs on budget hardware. And because of that, you also have a bunch of other issues that can come with Android Go, namely the lack of stability and performance issues. Because Android's a relatively heavy operating system, we'll often find that users are unable to use the full suite of services because they're unable to, say, multitask, or an app simply requires too many resources to run on their device. And again, these aren't issues with something that's being rendered in the cloud, like CloudPhone, because we have servers that we can scale as we need to.
Amazing. Thinking about smartphones, budget smartphones, right, in the context of our discussion, right, and also feature phones, for example, cloud phones and Android Go and stuff like that. So why do you think people still prefer feature phones in certain regions around the world?
It's certainly an excellent question, because I think a lot of people wonder. There have been trends, for instance, like a growth in the feature phone segment in Western markets, which have perplexed a number of people. In places where people have access to money and could buy a new phone, why would they willingly choose a feature phone? So I think there's a range of reasons. In Western markets, I think the primary market segment for feature phones are senior citizens, people who just want a basic communication device and need access to just a limited number of services. Children, so parents who want to intentionally restrict the things that their children can access so that they're not spending tons of time on social media or being able to access all of the dark corners of the internet. And then finally, digital detoxers. These are people who have found it really difficult to remove themselves from social media and the addiction to scrolling, so they will intentionally switch to a device that will restrict the levels of engagement that they have with their technology. And now in emerging markets, I think it's a very different segment. Again, affordability is key here. If we want to be able to connect the 3 billion people who currently don't have access to the internet, we need to do it affordably. Mm-hmm. And so they just simply can't afford something, higher end. I think another one, this one's often quite surprising. People keep feature phones as backup devices in countries that either have unstable power because you need the longer battery life that a feature phone will provide you, or where crime is high because smartphones are stolen far more often than feature phones. Most of the time, if someone's going to get something stolen, they're probably going to leave the feature phone because they don't think there's a lot of resale value, but they will steal an Android phone. So people will often have these as a backup device. You might carry a smartphone and a feature phone, and that way if your smartphone gets stolen, you still have the ability to call and text your family, maybe request assistance, get a ride or something. So there's a whole bunch of reasons that people are still using these devices, will likely use them for many years to come.
Amazing, amazing. So we've just talked about Cloud Phone and its missions and like basically what Cloud Phone is trying to do in the market, and I'm trying to understand from the market side of things, right? So we might get a little technical, right? Like this next couple of questions, right? Just to go into the technical part, because I think for this discussion, that was mostly the idea. But I just wanted the audience, right, to understand what Cloud Phone is before we jump into the technical aspect of it. So first off, I think you mentioned that Cloud Phones, right, are mostly built on Chromium based remote browsers, right? So can you just explain what that actually means for people that don't know what's a Chromium browser?
Yeah, so Chromium is just the open source version of Google Chrome. You can think of them as one and the same. If you're using Google Chrome today, then you're using Chromium. That means it includes the V8 JavaScript engine and all of the other components that come along with Google Chrome. And then remote browser basically means, unlike a traditional browser, where the connection happens from your browser to a server directly. So you're issuing HTTP requests or you're communicating over WebSockets. With the remote browser, there's a server sitting in the middle that's doing a transcoding. It's taking in the website all the HTML, CSS, and JavaScript and turning it into a representation that can be sent on a thin client. That means that the data transmitted between the user's browser, the thing that they're using, and the server that's doing the remote browsing is compressed, so you'll use substantially less data. And it's also being transcoded in a way that allows it to be rendered on devices with substantially less resources, less memory, less CPU. So you're not sending all the HTML, CSS, and JavaScript and running it on the device. It's running on a server. That also creates a layer of security because you're isolating yourself from the website. Because if you were to, let's say there was a zero-day exploit that allowed you to get full root access to whatever's happening in the browser, that lives in a server, not on your device, and so your device remains safe even if the server gets compromised. So there's a whole bunch of benefits here as to why you would want to use a remote browser, but really the key thing is that you have to. On this device category, there just is not enough power to run a modern website directly. There's no way that you could run even a single tab in Google Chrome without offloading some of that computation to a server.
Okay, amazing. So thinking about this right now, I'm thinking about the remote browser and stuff like that. So I'm just thinking about what are the key differences, right? The key differences for developing for a cloud phone and a traditional web browser. So now let me expand the question. So most of the audience, right, are mostly like web engineers and web developers, right? They have gotten to build applications for web browsers, our traditional web browsers, Chromium and like Firefox and stuff like that. So what are the key differences, right, when developing for cloud phones and also or developing for traditional web browsers?
Yeah, so generally speaking, the differences for developing for a remote browser will be probably the single biggest difference. There's no offline support. All rendering requires an active internet connection to a server in order to be able to do that transcoding that I mentioned. So if you're a web developer, that means you don't need service workers, you don't need to worry about caching, you don't need to do anything for offline support because the user can only access services while they have an active internet connection. So that's definitely the single biggest difference. Now, Cloud Phone specifically, I think the two other big differences are going to be the screen size for the terminals. So these phones are QQVGA. That is 128 by 160, or QVGA, which is 240 by 320. That's roughly, the physical screen size is roughly the same as an Apple Watch, with a screen density less than half of that of an Apple Watch, and a contrast sometimes 1/10 of that of an Apple Watch. So if you think about it, they're very small, they're fairly low resolution, and low contrast. So you need to be able to fit your website into a very small screen. The second thing is the navigation pattern. There's no emulated cursor in Cloud Phone. All apps use the arrow keys, up, down, left, right, so the directional pad, to be able to navigate. So traditionally this will happen through like a tab index. If you're a web developer, you're familiar with accessible keyboard navigation, where you can shift between elements using tab. It'll work the same way, but you have the ability to intercept the key events directly. Probably the closest experience that I could think of for that would be if you use a smart TV. You're used to having a remote and you can press up, down, left, right to go scroll through the grid of options on Netflix. It's exactly the same navigation pattern on Cloud Phone, just scaled way down to a very small screen.
Okay, amazing. So now, speaking about Cloud Phone again, can you just give us the differences, or should I say, how do they different from PWA, right? Like your progressive web app. So how does Cloud Phone what's the difference between cloud phones and your PWA? So your PWA basically is just a progressive web app where you could install your web application as an app, right, on your mobile phone, and you could access it as an icon, maybe on your phone, right? Can you just give us like, are there key differences of cloud phones, and how does cloud phone handle PWA?
Yeah, so today, most PWAs with some design changes will work on Cloud Phone. But there are a couple of key differences here. One is that there is no installation process today for Cloud Phone. Users will be they're able to access a grid of icons for different apps, and they launch it directly. There's no need to quote unquote install it. There's a few reasons why, but namely, again, going back to the technical restrictions of a remote browser, without offline support, there's really no added benefit to the concept of installation. So that's definitely the first difference between a PWA. The second is that as of right now, Cloud Phone doesn't actually require a manifest or most of the other technical requirements of a PWA. So if you're building a PWA today, you need a service worker, you need a web manifest, and you need a few other events that you're going to handle within your script and some optimizations. Most of those aren't necessary in Cloud Phone. Service workers will be ignored, manifests will be ignored. So you can think of it as like a stripped down PWA, if you will. But the gist is, if you have a PWA today, more than likely, if it works in Google Chrome, it will work on Cloud Phone too, with a few changes.
Okay, amazing. So let's quickly talk about navigation on cloud phones, right? So how does it different? How does it work? Actually, I think that should be the question. How does it work? Because most of the users of smartphones are used to touch-based smartphones, right? So if you're building for cloud phones, how does the navigation actually differs from a regular smartphone? Like, how does it handle navigation?
So for physical navigation, if you've got a device like this, again, you have a directional pad. So you have arrow up, down, left, and right. And then you have these two soft keys, soft left and soft right. This is true for most feature phones. So apps are allowed to intercept these as key events, as well as all of the T9 keys. So you can think about it like you would intercept a keyboard event, say key down, key up, and then you can respond to those events by shifting focus, by clicking into elements, etc. And the traditional model for these is that soft left will open a menu, soft right takes you back in navigation, and that's really all you need to worry. So if you think about it, there's really 4 arrow keys: enter, soft left, and soft right. So less than 10 keys that you need to worry about with a feature phone. And then there's default navigation. If you do nothing, if you just take your PWA and put it on a cloud phone, by default, it will use accessible navigation, so tab index, to move focus between focusable elements on the screen. So it might be that if your app was already built with accessibility in mind, it may just work on cloud phone by default.
Okay, that's quite amazing. So let's quickly talk. Okay, so let's quickly just talk about the APIs that are currently supported. So what's the plans? What are the APIs currently supported, and which one are currently in development?
Yeah, so Cloud Phone has a full range of APIs. You can think of pretty much anything that runs on Google Chrome today. One of the modern versions will work on Cloud Phone. To list a few, again, it's running the V8 JavaScript engine. It supports full ES6 or ECMAScript 2019. So you have all of the latest features that you would expect: async await, promises, anything that you expect from modern JavaScript environment. It supports all ACP versions, 1.1, 2, and 3, including Quick. It has all the content encodings you'd expect. For web APIs, you have full offline storage using IndexedDB or local storage, with the same quotas that you would expect on Google Chrome. You have multimedia support, so you've got audio and video, including HLS or HTTP live streaming. Interestingly, you also get full WASM or WebAssembly support. So you can build an app using native code, say something in low-level language like Rust or C, and you can compile that to a WASM binary and actually ship that. And because it's using Google Chrome, you have all of the same WASM support that you'd expect in Chrome. That means that you have access to the garbage collector. And just a few more, you've got Fetch, you've got WebSockets. For graphics rendering, I think I mentioned you have Canvas and OpenGL. You've got all the same CSS properties that you'd expect. You have custom elements. So really, it's most things. And now I'll just add, there are a few things that are currently in development today that are specifically relevant to the feature phone segment. One is push notifications. We don't have that yet, but it's in progress. WebRTC is another one that we're actively developing. So the ability to establish peer-to-peer connections and do live streaming, which you could imagine would enable, say, like video chat, would be a big use case for that one. So those are two big features that we're working to bring to these devices. But as you can imagine, because of the constraints of the physical device and the hardware that runs inside of them, there's a lot that we have to do to make that support happen. And then I'll add one thing that isn't coming to CloudPhone for anyone working in multimedia, unfortunately, would be digital rights management, or DRM. Because of the way that remote browsers work, because the decryption happens on the server, not on the end client, it technically doesn't support end-to-end encryption, which means that DRM is not possible. So any multimedia that's restricted through DRM, unfortunately, won't be able to load on CloudPhone.
Okay, so amazing. So speaking about the limitations, right, developers could get to experience while building for cloud phones, because I think you've talked about a whole lot of stuff about cloud phone, talk about the APIs, and it's kind of exciting, because if you say we have access to all the APIs that are available, right, on your Chromium browser, for example, Google Chrome, right? And you could basically ship your app, right, to your remote browser and make it available on CloudPhone with those features like available right now. Sounds very, very amazing. So speaking about the limitations, right? So are there any limitations you think developers should be aware when they are building for cloud phones, or when they're targeting cloud phones?
Yeah, probably the biggest limitations I was alluding to earlier is anything where the API requires access to the physical hardware. We either haven't developed it yet or may not plan to develop it in the future. So a couple of examples of this would be the geolocation API that you would use for GPS access. We don't support that today. There may be plans in the future to support that, but it's not something we currently have. Another one would be web Bluetooth. There's no plans to support this simply because the complexity of the stack and the variety of hardware that we would have to operate in makes it very difficult to be able to integrate directly into the Bluetooth chips on these phones. And then clipboard is maybe another sort of funny one. There's no copy paste because there's no text selection, because it would be quite difficult. So we don't support the clipboard API, or battery, for instance. That's something that we haven't built yet, but you can't access the battery API, so you can't know the battery level. Basically, if you think about it, if you need to access information from the user's end device, the hardware itself, we may either not have built it or it's in progress. So I think that's really the primary limitation here.
Amazing. I think you just mentioned most of the limitations that you could get to experience while building, for example, maybe on desktop or other platforms. Okay, amazing. So thinking about the API documentation and what the team has to offer to developers right now. So how could developers access the documentation? And I don't know, let's just talk about the API documentation right now. What's the adaptation level before you could start building for cloud phones? So on top of my head right now, I could think about this. Basically, if you're familiarized with web development, if you know how to build for the web, you could basically run your app on cloud phones just with maybe some little tweak. But I just want to hear from you, because I think you're the expert in this, right? So what do you think are the requirements before one could start building on cloud phones? I think let's just start from there.
Yeah, so I think you put it pretty well. If you're a web developer, you can already develop for CloudPhone today. There's really no special skills that you'll need. You can think of CloudPhone as basically a subset of Chromium, but it has most of the features that you're probably used to. In terms of whether or not you want to build for this market, I think it comes down to the markets. So again, CloudPhone's primary markets, where it has over 1 million active users in just its first year, this would include countries like India, Pakistan, Bangladesh, also countries like South Africa, Vietnam. So the major markets here are going to be Africa and South Asia, simply because this is where this device category is very popular. So if you are building a product that you want to be able to be available to this segment, then it's sort of a no-brainer, especially if you already have a technology today, like a PWA. You can just make a handful of changes and have it support CloudPhone automatically. And you can do a variety of, if you're thinking about adapting your PWA to CloudPhone, you can think about it from the perspective of standard web technologies. So you might use like CSS media queries to detect the really small screens and then make style changes to fit them. You could do device detection instead of feature detection, and you can see if the context you're operating in, if the user agent includes CloudPhone, then you can maybe remove some features that aren't relevant to that device. So again, it should be pretty simple. If you have a PWA, if you're a web developer today, you can get started. You can go to developer.cloudphone.com. You can access all the documentation. You can get links to sign up for a developer program, which is completely free. You can access the online simulator, where you can see what your website or PWA looks like rendered on CloudPhone. And then if you're in one of the many countries with a CloudPhone, you can buy one of these devices and enable developer mode so that you can actually test the widgets that you're developing on a real device.
Amazing stuff. So thinking about the development experience, right? Because we've talked about how you just being a web developer is enough for you to build for cloud phones. And I think you actually touched a point which was going to be my next question, right? How could developer test? I think you already said you could go to the documentation, and you guys have a whole lot of resources for developers to check out. Then you could also get a cloud phone from the market, and you could activate developer mode, which is amazing, right? So you could just basically test out your cloud phone, see how it looks like in the emulator or on an actual device before pushing it out to the market. So now, one question on top of my head right now is this. Now I want to build my application, right, for cloud phone and also a regular traditional web browser. So let me expand the question right now. So me and my team, right, we're looking at expanding to different markets for our products. Let's say a particular web application, right? We're targeting cloud phones, which feature phones, right? And we're also targeting traditional web browsers. What do you think would be the development workflow right now? So will it be the developers are just going to focus on building for the traditional web, then they could just quickly just take it over to cloud phones? Or do you think they need to be a different development team, right? In quotes, in the context of what we're talking about right now. Do you think there should be a different development team? Or do you think if the developers are taking over their web applications, right, which runs well in the traditional browser into cloud phones, do you think they will need to do any tweak or any changes to make it work on cloud phones, like streamlessly the way it already works on the traditional web browser?
So I can tell you a little bit about what people are doing today, which is definitely the vast majority of cloud phone apps today are actually multi-platform apps that run on a variety of other web contexts and have only recently been brought to cloud phone. So this might mean that you took a KaiOS app and brought it to cloud phone. Maybe you took a PWA and brought it to cloud phone. But really, there's no need for a separate app. If you were developing for KaiOS, you'd have to put substantial time and effort into optimizations and refactoring to be able to support the hardware that you're operating on, the restricted API use, and the outdated rendering engine. But because Cloud Phone is using a very recent version of Chromium, because the servers have plenty of memory and CPU available, you don't need to worry about most of these things. So I would say you don't need a separate development team. If you have a PWA or you're building a PWA, really the only things that you need to start worrying about would be accessible navigation using the keyboard, and then being able to scale down to viewports as small as QQVGA. Because what I'll say is if you're working with tools like Bootstrap or Tailwind, most of these tools are not going to have CSS breakpoints that go as far down as QVGA or QQVGA. Most of them are going to stop at probably like a small 480p resolution, and they're going to go all the way up to desktops that are I don't even know anymore, over 2,000 pixels in width. So most of these tools aren't thinking about the really small end. So that would be probably the biggest task, would be adapting your layouts and adapting your designs to fit screens this small. But beyond that, there's really nothing else you need to worry about. You don't even need to worry about things like scaling down your assets or images, because Cloud Phone will do that for you, and it transcodes it and sends it to the client. So if you have an image that's, say, I think about this in the context of if you're using like an old WAP browser, something like Opera Mini, or even one that doesn't do transcoding like Dorado, if you try to load an image that is, or here's a really concrete example. So my app PodLP runs on KaiOS and Cloud Phone. In KaiOS, it has to create thumbnails for each of the podcast artwork, because podcast artwork is often 2,000 or 3,000 pixels in width, which means that the files could be 4, 8, 10 megabytes in size. I have to do that work in my app to shrink them down on the server before it goes to the client, because it would cause an out-of-memory error. In Cloud Phone, you don't need to do that because the servers will do all of that work for you. It's not a bad thing if you have the ability to use the source set attribute and multiple image resolutions. You'll certainly save bandwidth and efficiency from your side, but you don't need to do those things to support Cloud Phone today.
Amazing. Thinking about this now, what type of application do you feel could perform well on cloud phones, right?
So today, I think some of the top engagement apps would be streaming services like TikTok and YouTube. Those do phenomenal. Users, the interface is just, especially YouTube Shorts and TikTok, the swipe left, swipe right using the keyboard is just so easy and simple. Information apps do very well. Wikipedia and BBC News are pretty noteworthy examples. Sports apps like QuickBuzz to check cricket scores, those do pretty well. My podcast app, PodLP, is a good example of one that works quite well, because you can stream audio pretty effectively on these phones. You don't need to have a huge terminal to do this. So really anything that you think can run pretty well on a device category like this. Now, in terms of what wouldn't go well, though, I would say games can do well, especially puzzle games, but real-time games won't work because of the remote browser technology. So something we maybe didn't touch on is that because of the way that CloudPhone is architected, there's a server sitting in the middle that the client communicates to. There's a limited number of screen refreshes that are possible in a given time, just based on the round trip time from the user's device to the CloudPhone servers. Now, based on the current latency, that means that you get about 20 frames per second on a stable internet connection. That's not enough for a real-time game. Plus, maybe a bigger issue with real-time games is the state getting frozen. So if you're developing a game, puzzle games would do quite well, guessing games, information-based games, but real-time action games, probably not well suited for these devices. So yeah, the short answer is really anything that this user segment, would benefit from. Anything that you'd expect someone on Android Go in these countries to use, messaging services, information services, all of that will do quite well in CloudPhone as well.
Okay, amazing. So I think you already mentioned reward examples. So can you just give us some good examples, right? Your reward examples of businesses, or should I say developers, basically using cloud phones, like successfully built on cloud phones and launched on cloud phones. So are they examples of businesses or developers you basically know about that they had a success launching on cloud phones?
So we don't have as many examples for independent developers. Most of these are companies that already had a web app that we were able to bring over. Like I mentioned, we've got most of the social media, so Facebook, Instagram, we've got YouTube, TikTok, BBC News, and Wikipedia for information. But we also have a number of developers who have built things, utility apps like weather, notes, maps. These are doing very well. They have high engagement, things that users want to use regularly. So really, I would say if you're a developer today, one of the biggest advantages of CloudPhone is there isn't a crowded market. When I was doing some research, I think as of the start of this year, there are more than 3 million apps available to install in Google Play. And the average cost per install, if you're doing a paid campaign to get users, is between $1.50 and $4. That means that every user that you want to get through ads on Android is going to cost you about $1.50 to $4, or think about it like every 1,000 users is $1,500 to $4,000. CloudPhone, because there's just comparatively so few apps, I think we're still under 100, although we're getting close. It's very easy to stand out and build something that hasn't been or isn't available today.
Okay, amazing. So speaking about the future plans and developers that are interested in building for cloud phones, right? I think we already mentioned there's a documentation, right? So are there tools, are there other resources for developer interested in building for this particular ecosystem, right? So are there other tools or resources apart from the API documentation, which we mentioned? Are there other tools out there for developers?
Yeah, so I think I mentioned all the other tools. So again, you can go and access all of this information from developer.cloudphone.com. So you can register for the developer program, you can access the simulator, you can add widgets to a list for testing, you can add the IEMI of your device so that you can actually test your widgets on a physical device. All of that's available. We're currently working on a remote debugger. So think about this like the same debugger that you would use in Google Chrome today, where you have tabs for console, network, styles, etc. All of that would be available to you directly within the browser to see from the simulator exactly what's happening within your app. We've also got a Reddit community and a Discord server, so r/cloudphone, and a Discord server by the same name. And you can also, if you're old school, you can email us directly, cloudphone@cloudmosa.com. And again, all of these resources are available on our website. And so with all of that, I guess the final thing I would add is, I think I showed this device off earlier. This is actually one of our developer units. So for developers in the United States and the EU, we also give these away. So if you're interested in building CloudPhone apps, we can send you a developer device. They've got support for all US and EU 4G bands, and we're working on more. So we're working on getting a developer device that would be Wi-Fi based too. That way we're not restricted to, the certain frequency bands that are available in different regions.
Okay, amazing. So are there any upcoming features developers should be looking out for? Upcoming features and improvements the team are currently working on, right, to improve? I think you just mentioned one, right? The debugger. Right, so having a debugger, something similar to what we have on the Dev2, Google Dev2, right, Chrome Dev2. So are there any other upcoming features or improvements developers should expect in this particular ecosystem coming from cloud phones?
Yeah, I think we touched on them all here. So the remote debugger is going to be huge from a developer perspective in terms of being able to actually understand what, if any, of the differences are happening between Chrome and Cloud Phone, to be able to test a bug, and then fix them before you ship your widgets. So that'll be a big one from a tooling perspective. And from a feature perspective, I think the two biggest that I mentioned would be a web push. We don't have this today, but the ability to do push notifications will help drive user engagement to your apps. It'll be critical for messaging services. So if you're building an app where you're, say, talking on Matrix or Discord, well, you'll need those push notifications. App badging goes in hand with push notifications. So the ability to put a number on the app icon on the home screen, like 1, 3, 5, 10 plus, to show what the number of messages or interactions that you have in your app are. And then finally, WebRTC. That's going to enable a whole new set of communication apps, like live video chatting with your family and friends, both between cloud phone devices and between other devices. So you could be chatting on a cloud phone with someone on Android or desktop, or even be a guest on a podcast like I am right now.
Amazing. So speaking about the future of cloud phones, right? Where do you see cloud phone in the coming years? Like 5-10 years from now. So what could you say about the future of cloud phones?
Yeah, it's a great question. The future of cloud phone, I think in 5 or 10 years time would be, it would be nearly ubiquitous on any feature phone that's still being sold. So every feature phone you would see would be a cloud phone. It would have access to all of the same services. I imagine a wealth of apps would be available. So we'd start to redesign the App Store to be able to handle the larger catalog of apps. I would hope that most of the major apps that you would expect today, including messaging services, would be available. In that time frame, I'd like to see us fully support end-to-end encryption, so that way you can have messages being decrypted on the user's device and rendered on screen. And then I expect different device categories. Feature phones are just one type of resource-constrained device, but there's really no reason to limit the type of interaction pattern. Like you could have cloud phone. To give you an example, the Puffin browser started on Android in the very early days, back when Android phones were very resource constrained themselves. So if you were using the Chrome app on, say, Android Eclair, Android Honeycomb, some of the very early versions, the performance was terrible. Websites either wouldn't load or they would crash because it would run out of memory. So Puffin did phenomenally well during that time. But now, flash forward to today, Android phones are so powerful, especially in Western markets, you don't need that. But there's no reason that we couldn't have cloud phones with touchscreens. So I think that'll be a whole new device category, basically ultra budget touchscreen devices where users are able to access web services through cloud phone, just like you would access websites through Puffin, but on devices that are using maybe, a fifth, a tenth of the hardware that Android Go requires today. And yeah, there's a whole bunch of other use cases that are going to be in the future, but I think those are probably some of the biggest ones.
Yeah, I think it sounds amazing, right? I think for me, what I'm mostly interested, right, it's the affordability range for cloud phones, right? Being able to afford such phones that gives you such capabilities and for a very low budget, like for a low budget price. So it's really amazing, and really looking forward to the future and what it has to offer, right, for cloud phones. So for developers interested in cloud phones ecosystem, I'm going to leave links to the documentation and also the API, and also I think how you could reach out to the team if you have questions, if you really have questions for the team, right, about cloud phones and how you could get started and stuff like that. We've come to the end of the discussion about cloud phones, and I hope the audience, you listening right now, enough insights about cloud phones and what it has to offer. And if you're interested, you could jump into the documentation and start building. Tom, thank you for coming to have the discussion with me, taking out time to have the discussion with me. And I think this should be the end of this episode. Thanks, Tom.
Thank you for having me. It was a pleasure.